Hi, this is Neil Davis from Digital Cloud Training. In this video, I'm going to walk you through some practice questions from my AWS Certified Solutions Architect Professional Practice Exam course. Now, my aim is to give you an idea of the type of questions you're going to see on the real exam, give you some tips for how to answer them correctly. Now, the real exam has 75 questions. You get 180 minutes, so 3 hours to take the exam. And a lot of the questions can be quite challenging, quite lengthy, and quite tricky as well. So time management is a really important tip. Make sure you don't spend too long on one question. If you get a bit stuck, do your best, give it a good answer, and then mark it for review. And then go through the exam. You will find that between the tricky questions, you'll find a few that aren't so tricky, and you should be able to go through them quite quickly. So that way, at the end, hopefully you've got some time to go back and answer those tricky ones and give them a bit more time. So let's get started. I'm going to go through 4 questions today, and these will definitely represent the type of questions you're going to see. So let's see what we've got first. As you can see with this question, you've got 4 answer choices. Now, when you have 4 answer choices, it means that you have to choose one of them. You'll see other styles in the next questions that we're going to look at. So let's go through this one. A company is planning to move to the AWS Cloud and is creating an account strategy. There are various teams in the company, and each team prefers to keep their resources isolated from other teams. The finance team wants each team's resource usage separated for billing purposes, and the security team will provide permissions to each team using the principle of least privilege. Now, as soon as I read this question, straight away AWS organizations comes to mind. You get quite a few questions on AWS organizations in the CSA Pro exam. So let's go through the answers and see what makes the most sense. And we can see straight away we've got at least 2 here which include organizations. So let's start from the top and work down. Use AWS organizations to create a management account, makes sense. Create groups in Active Directory and assign them to roles in AWS to grant federated access. Apply tags to the resources for each team and separate the bills based on the tags. And then control access to resources through IAM, granting minimum privileges. Well, definitely creating a management account makes sense in AWS organizations, but the federation piece, well, that doesn't make a lot of sense. There's no talk in the question here about federating to any kind of on-premises directory. So you definitely need to know use cases for that. There are questions that will come up that test you on your knowledge of how to federate from some kind of on-premises directory into AWS. But this question doesn't seem to require that, so that doesn't make a lot of sense here. Apply tags to the resources for each team and separate the bills based on tags. Well, you can use cost allocation tags in AWS, and that means that you can separate your resources for billing based on things like the project that someone's working on. But in terms of this particular question, the finance team wants each team's resources separated, but we also want isolation in the team. So how are we going to isolate the teams? Well, I think isolating the teams, for me, is better to put them into separate accounts. And then you can use consolidated billing with AWS organizations, which is already going to give you a separate bill per account. So that would make more sense. So I'm going to just flick down to this bottom one now, actually. And I think this is probably going to be the right answer because I know I want to use AWS organizations, and the top one doesn't make sense. So let's check this one. Create a management account and create each team's account from the management account. In AWS organizations, you create your management account. It used to be known as a master account, and you will see that terminology still on the exam, so watch out for that one. But they have renamed it to management account now. So you create a management account, and then from that account, you can then create other accounts, and they become part of the organization. You can form a hierarchy. So that makes sense. And now each team has its own account. They're isolated. And using consolidated billing, we're going to have a separate bill per account. So that already fulfills a lot of requirements. Create a security account for cross-account access. Now what we're doing here is we have a separate account where we're going to create our identities. And the reason we do that is because the management account is a place where you can control your AWS organization and apply service control policies to limit permissions in the other accounts. But you don't want to put your identities in there because you can't apply SCPs to them. So you put them in a separate security account, and then you do cross-account access from there. So users have identities in the security account. They then do cross-account access to assume roles in other accounts where the actual resources are. So I like that question, I like that answer rather. That makes the most sense to me, but of course we always have to go and check the other answer choices to make sure they're not correct. So create a new account using CloudFormation to provide teams with the resources they require. You could create a new account in CloudFormation, sure. Use cost allocation tags and a third-party billing solution to provide the finance team with a breakdown costs based on tags. Now, as soon as you see the words third party, to me that's a bit of a flag because you very rarely find AWS answers are going to include a third-party solution when AWS can perfectly well fulfill these requirements without any need for any third-party software. So I don't like that one. There's lots of reasons why I don't like it. We don't need to use CloudFormation to create the accounts. We can use organizations. Cost allocation tags, again, we've got consolidated billing in organizations, so we don't need that. Third party doesn't make any sense. So that one doesn't look good. The next one here, create a separate AWS account for each team. And let's just make sure I go back and select the correct answer. So the next one, create a separate AWS account for each team and assign the security account as the management account and enable consolidated billing for all other accounts. Doesn't make a lot of sense already because you wouldn't do it this way, so you wouldn't assign a security account as a management account, I explained that before, and you don't enable consolidated billing in the other accounts, you would just enable it when you create your organization. So definitely like this answer at the bottom here. Let's just check that one out, and that's the correct one. And so we got lengthy explanations. All of the questions in the course have lengthy explanations, lots of diagrams as well, and this particular diagram just gives you an overview of AWS organizations. And you can see here, you have the management account, you get the consolidated bill. You are able then to create your different accounts, in this case, development, test, and production. And then you can apply service control policies to those. So let's move on now to the next question. So now we have a question with 5 answers, and here you have to select 2. So a company has recently established 15 VPCs within the US East 1 region. The company has also established a direct connect to the region from their on-premises data center. They need full transitive peering between the VPCs and the on-premises data center. Which combination of actions is required to implement these requirements with the least complexity? Now, one thing about the wording here in the question, just watch out for where it says combination of actions. The key thing to note here is that what this means is you do need to have multiple answers that are working together. They're part of one solution. Sometimes it won't say combination of actions and it will say which options. And that means there could be 2 different options which both fulfill the requirements. And you wouldn't necessarily do both of them, but they both could be, potential solutions. So in this case, it's a combination of actions, and least complexity is an important keyword here. So what can we do here? So we want to create transitive peering. Now, one of the first things that comes to mind when we talk about peering with VPCs is VPC peering. But as you know, you don't get transitivity with VPC peers. So you can't transitively connect VPCs. That means if you have 3 VPCs, you need a connection between all of them. When you have 4, each one needs a connection to every other VPC. And the number of VPC peer links that you have to create becomes huge. So in this case, there would be literally dozens of VPC peering connections, lots of route table entries, gets very complex. So I don't like VPC peering, so I'm straight away going to look for answers that mention that so I can eliminate them. So at the bottom here, we can see create VPC peering connections between the VPCs in a fully meshed topology. Now it would work, at least in terms of the peering within AWS, but it's going to be a complex solution. So, it's not going to work in this case. So let's have a look at the other answers. We've got create IPsec VPN connections between the VPCs in a fully meshed topology, and then update the route tables. Now, of course, you can create VPN connections between your VPCs. Now, you can't use the AWS managed VPN. You'd need to run something like an appliance or an EC2 instance, and then you'd need to create your VPN connections between those. Very complex, not required in this solution at all. There are definitely better ways. So let's go down and look at the next one. Create an AWS Direct Connect gateway and attach the gateway to a transit gateway and enable route propagation with BGP. So this makes sense, and the transit gateway is an interesting one. We've got to check that out first, I think. So let's go down to the next one. Create a transit gateway and add attachments for the VPCs and then configure the route tables in the VPCs to send traffic to the transit gateway. Now the transit gateway solves that problem of complexity with VPC peering connections and the lack of transitivity. What it means is you connect all your VPCs into the transit gateway, update their route tables, and now they can transitively route between all of the different VPCs. So that's a really good solution. It gives us those transitive connections between the VPCs within AWS. So that's great. And then this solution here seems to complete things, because what it does is allows you to connect from your on-premises data center with that physical private connection using Direct Connect, and then connect that DX gateway to the transit gateway. So now you connect from your on-premises data center. You can have Border Gateway Protocol BGP for the routing, so you can have your routes flowing through and propagating. And that gives you full transitivity now, right from your on-premises data center into AWS. So those two answers make a lot of sense. Now we didn't check this one out, so let's just go and make sure that we don't want this one here. So this one says create a DX gateway and associate the DX gateway with a virtual private gateway, a VGW, in each VPC. Now a DX gateway is a great solution for connecting to VPCs in different regions, for example. But in this case, the transit gateway is the better solution for connecting the VPCs within a region. So what we want to use the gateway for is just connecting to the transit gateway, not connecting directly into the VPCs. So I like these two answers here. Let's click on check. Those are the right ones. So let's just scroll down and you can see a nice diagram here. So this is how it looks. You've actually got your customer router in your corporate office, your on-premises data center. You go through the customer partner cage, the AWS cage, and this is your direct connect link. And then you've got a DX gateway. And the DX gateway then connects you to the transit gateway, and the transit gateway has connections into all of the different VPCs. So that's how that works. So let's move on now to the next question. So this is an example of the third question format you're likely to see on the exam. In this case, you get 6 answers and you have to select 3 of them. So let's have a look at this one. An e-commerce website consists of a 2-tier architecture. EC2 instances in an ASG are used for the web server layer behind an ALB, and the web servers run a PHP application on Tomcat. The database layer runs on an Aurora MySQL database instance. Now straight away I realize as I'm reading this is a really long question. Now there's something really important I want to tell you about this exam. Sometimes you get really long questions and sometimes the answer choices are very long as well. And the thing is, when you get longer questions or longer answers, I find there's more clues. So on the one hand, you see these big questions and think, wow, that's a lot of information to process. But I like to reframe that and think, well, actually, this just gives me more information, and more information means I can make a better decision. So let's carry on reading this question. Recently, a large sales event caused some errors to occur for customers when placing orders on the website, and the operations team collected logs from the web servers and reviewed Aurora DB cluster performance metrics. Several web servers were terminated by the ASG before the logs could be collected, and the Aurora metrics were not sufficient for query performance analysis. So what combination of steps should a solutions architect take to improve application performance visibility during peak traffic events? So we've got some particular issues that occurred here. We've got EC2 instances and we've got an Aurora MySQL database. We didn't get the right information from Aurora, and the web servers got terminated by the ASG and we lost the logs. So what can we do here? Well, let's look at these answer choices. We could configure the Aurora MySQL DB cluster to generate slow query logs by setting parameters in the parameter group. Now that actually is a good solution because we can do that. We can actually generate some more logs which should be useful for this kind of performance monitoring. So I like that one there. Configure an event bridge rule that triggers Lambda upon Aurora error events and saves logs to S3 for analysis with Amazon Athena. Well, I don't see a requirement to do that because we can do it with slow query logs, so we don't need to use event bridge and Lambda. That's becoming a bit too complex there. If there's built-in functionality to actually gather this information, do your performance metrics, auditing, logging, whatever it is, then you should use those. AWS are not going to push you to create some kind of custom solution if the functionality already exists. So next up, use CloudTrail to collect API activity from EC2 and Aurora and analyze with Athena. Well, in this case, there's no reason to collect API activity information. We're looking for performance problems. We're looking for the reasons why an error occurred on the website, whereas CloudTrail is going to give us API auditing information. So I don't think I want that one either. Install and configure the CloudWatch Logs agent on the EC2 instances to send the Apache logs to CloudWatch Logs. Well, I like that one. So if you install the CloudWatch Logs agent, you can stream the logs straight to CloudWatch. So the good thing about that is if your instance terminates for some reason, maybe the ASG terminates it, then the logs have already been streamed. So if something happened 5 minutes ago, that's fine. That information is already in CloudWatch. And that's one of the problems that we had here. So I like that option. Implement the AWS X-Ray SDK to trace incoming HTTP requests on the EC2 instances and implement tracing of SQL queries with the X-Ray SDK for PHP. I like that option. X-Ray is a great tool when you have an architecture with multiple layers and you're trying to work out what's happening between those layers. It sort of fills in that picture, whether there's delays, that kind of thing, what's going on with one layer talking to another one. And in this case, you can actually use the X-Ray SDK for PHP, and that's going to give you some important information there on SQL queries. So we can see what's happening with those queries coming from the front end that are going to talk to the MySQL layer. So I like that option as well. I think that's the third option there. The last one says, configure the Aurora MySQL DB cluster to generate error logs by setting parameters in the parameter group. In this case, we know that some metrics were collected from the cluster, but it says that the logs were not sufficient for query performance analysis, which is why I'm going more towards the slow query logs rather than the error logs. So I like these three options. Let's just click on check. And that's certainly the correct answer there. So this is the last question. A company stores highly confidential information in S3. The security team have evaluated the security configuration and they have some new requirements. They now require the ability to identify the IP addresses that make requests to the bucket and then be able to identify any kind of malicious actors. And they also want to make sure that any changes to the bucket policy are automatically remediated and their team members receive alerts. So how could we do this? Now, a quick tip with pro level questions, especially with the longer ones. This isn't a particularly long one, but you do need to go through any questions and really sort of distill down the particular requirements. So sometimes they can be quite wordy and you need to try and make sure that you understand what's just part of the wording or what's superfluous, and then extract the requirements out of the question and then use those. What are the variables? What are the requirements? So the requirements in this case are simply that we need to be able to identify the IP addresses that make requests to a bucket, automatically remediate any changes to that bucket, and then send some kind of alert to the team members in the security team. So let's look at the first answer. Use CloudWatch Logs with Athena to identify the IP addresses in Amazon S3 requests. So let's look at the first answer here. Use Amazon CloudWatch Logs with the Athena connector to identify the IP addresses in S3 requests. Well, does that work? Well, CloudWatch Logs is not going to have that information. If you use CloudTrail, then the API actions would be logged, and that could include the request, the IP address of the request or the caller. So in this case, CloudWatch Logs isn't going to work. Can you use CloudWatch Events rules with Lambda to remediate bucket policy changes? Certainly possible, but the first part of the question is definitely wrong. So let's move on to the next one. Use Amazon Macie to identify the IP addresses in S3 requests, and then use Lambda and Macie to automatically remediate S3 bucket policy changes, and use Macie for automatic alerting. Macie is a tool that you should use when you're looking for personally identifiable information in data that's stored in Amazon S3. In this case, we're looking for the IP addresses of the callers, so the requests to S3. So I don't think Macie is the correct answer. Create an AWS Cloud trail and log management events, and then use CloudWatch events rules with Lambda to automatically remediate any policy changes and alert with SNS. So the first bit here doesn't work. CloudTrail trails can log this information. They can log information about the objects, what's happening to the objects, the calls that are being made to them. But in this case, management events are being enabled, and management events won't log that information. So that's definitely not going to work straight away. So I can rule that one out because I know that you need to enable object level events to get this information. So let's look at the last answer. I've eliminated 3, so I'm hoping this is the correct answer. Identify the IP addresses in S3 requests with S3 server access logs and Amazon Athena. Well, S3 access logs do log information about the requests that are made, including the IP addresses. And Amazon Athena is a way that you can then run SQL queries to look at data in S3. So you would be able to run some queries and find those IP addresses, identify any potential malicious actors. And then it says use config with auto remediation to remediate any changes to S3 bucket policies. Again, definitely something you can do. I like that. You can use AWS config to manage the compliance of your services in AWS, and it can do auto remediation on bucket policy changes as well. And then finally, use config and SNS to send alerts. So config will trigger SNS and SNS will alert the team members. So that's a good answer as well. So I like that option. Let's just check this answer. And for sure, that is the correct one. And there's an explanation here, as always, giving you the explanation, not just for the correct answer, but for the incorrect answers as well, to help you understand, why they're not correct. That's it for this video. I hope that was useful to you, and I wish you all the best in your Solutions Architect professional exam.